scope of physics is very much wide. We cannot move away from this concept that physics can be end. Physics cannot be end by any means. So I can say the scope of physics is start from a very small, minute atom, and in that nucleus, and in that neutrons, protons, and in that also quarks and many other parts of nucleus. That includes in nuclear physics. To the major part, the biggest part of this whole universe. What is that? Universe itself, which has a limit of 2 raised to the power 25 meter large. Such a huge limit. Yes, we deal with that. So that's our field. We always say, no, that's my area. So physics area doesn't end at any point. With that note, I can say the scope of physics is everywhere right now. I am streaming on YouTube with the help of you guys to make a comfortable video for you guys and make it possible to do these studies in such a pandemic, as well as to keep yourself safe. Okay, with that note, I can say the scope of physics lie behind this particular laptop, lie behind in this particular TV. You all watch IPL? Yes. We all watch cricket match, live cricket match. Yes. We daily watch our live telecast, whatever going on. Many more live news. Yes. That's the scope of physics. A very large amount of data records stored in computer, large memory. Scope of physics. High speed. In spite of having large data. Scope of physics again. Use of robotics, robots, lasers, their application, optical fiber communication, no end. Everything included in scope of physics. Chemical bonding, you say it's a part of chemistry, good ma'am. No, it again a part of physics also. Because physics used to study about neutrons, protons and electrons and their atomic number. Yes, we used to deal with that also. We used to deal with atomic structure. We used to deal with atomic nuclei. We can't get away from chemical bonding again. We deals with atomic number, complex structures and electrostatic forces. Also, electromagnetic forces. Number of forces are there which we are dealing in. Afterwards, there comes a concept of relationship. He said, I have a nice field of area and I rule over everyone. Biology. Then physics say, oh, hello, it's okay. You have a large area. But without me, without the help of mine, you won't be able to study biology. You won't be able to find a single result in biology. He said, how come? He said, have you heard about optical microscope and electron microscope? What can you do without that? Biggest thing to think about. Then he said, how can you check out, how can you study, how can you, I can say, how can you examine the biosamples? Yes, you can with optical microscope. Then question again came up. What is electron microscope then? All right, come down. Biosamples is very easy to understand, to examine. What if you went to a smallest part of living organism, that is cell, and in it there is a nucleus, and in it there is a nucleolus, and many more particles, many more smaller cell organelle. What about them? You have to understand all those things with the help of electron microscope only. He said, thank you. And there they made a bond with physics. So yes, physics it plays a very important role in the field of biological sciences. And if you all know, I hope you all know about, see, what is this? That's a bone, right? What kind of bone is this? Is that a spinal cord kind of thing? Any bone. X-ray is a bone. You can check any crack, any problem in the bone, any hairline in the bone with the help of X-rays. Okay, You can treat cancer. People used to say chemotherapy, radioisotopes. Yes. So biology has a huge entire world of it, but still physics plays an important role in it. Then they come back and they went to astronomy field. Then astronomy people says, okay, you defeated biology, you have a good relationship with biology, and you can't physics biology can do well, can't do well. It can't do well without your support. But we actually doesn't need you anymore. We are self-sufficient. He said, how come? If he has a microscope, you have a telescope. Well, yes, it's a part. You cannot design the telescope without help of mind, without the help of knowledge of light, rays, wave, lenses, power. We have to understand this thing with the help of physics only. So, you can check out the planets with the help of astronomical telescope, and to go beyond the limits of distance, universe, you have to go through radio telescope. Astronomy say, oh my God, thank you physics for such an important role that you have played in our life. Then other sciences also came up. Hello physics sir, how about you? I think you are great, but we are self-sufficient. Then come up to biophysics, oceanography. See the beautiful water flowing over here. And this beautiful water which is flowing over here deals with oceanography. And how oceanography will work? Its motion will work with the help of physics only. Seismology, seismograph, used for earthquake. See, you can see how the tectonic plates try to move, and you can see how volcano eruption happens, like how volcano got the lava of volcano came out of it and become magma, you can say. Okay, then fundamental forces in nature, gravitation force, physics, Newton's law of gravitation, frictional force, kinetic energy converted to heat, try to stop the motion, physics, contact forces, things which just came in contact and then try to pull or push and apply any kind of forces, contact force, microscopic forces, many more smaller nuclear forces, strong nuclear force, weak nuclear force, electromagnetic force, interatomic force, microscopic forces. Nothing can do without physics. They all have the relationship with each and every science aspects, as well as archaeology. If we talk about archaeology, do you think archaeology is possible? No. Do you think people can study about fossils and they can count the age of tree, fossils, and many more? You can see the oldest. We used to study about civilization. Is it possible for us to understand all these things, the history, without the help of science? No. Technology helps us to study all of those. With that note, I'm ending up the relationship of physics as we came to know that there is nothing, not a single field that can work without physics. He said, okay, boss. Come back to our next topic, that is called as fundamental forces in nature. What are the fundamental forces in nature? As I have already told you, that physics in itself plays a very important role in all types of motion and forces applying in this universe. So in that note, if I say that gravitational force is just a force which earth is applying on the objects, is just a force which sun is applying on the object, no. Due to this force, atmosphere exists in earth, not on moon. Due to this force, we all are having a life over here. Otherwise, tree must be flying upward. Otherwise, I used to be flying upward. I can make my video like my laptop is floating somewhere else in some other direction, and I would be floating on this particular universe if there won't be any kind of gravitational force. But yes, gravitational force in itself include many other concepts. Yes, like unification. Newton's law of gravitation deals with many more other fields like unification, you can say. And in unification, there are number of concepts which can be studied with the help of Newton's law of gravitation. In this, a single universal law of gravitation or Newton's law of gravitation shows many other operations like apple falling to ground, moon revolving around earth, weightlessness in rocket, you can say weightlessness in lift, you can say weightlessness in swings. Many a times when you are on swing, you always feel like something is going on in your stomach. You just feel like we are just like feathers and we will going to fly up and just fall down from that particular swing. It got scared. Yes, it's a scary thing. So in that case, I can say a number of forces can be explained. Number of forces can explain thousand number of phenomena. We try to do what? We try to accumulate all of them in a single fundamental law. So in that case, we have included a number of phenomena in a single law and thus provide four basic forces. There are number of forces you have heard about. You have heard about contact force, you have heard about non-contact force, you have heard about magnetic force, you have heard about electric force, you have heard about frictional force, you have heard about muscular force. What are you saying, ma'am? How could these forces be only four? There are many more. There are number of forces. How can you just say there are only four forces? No, this can't be done. Not possible. Then I say, yes, it is possible. If I talk about frictional force, what is a frictional force? When the particle of one body and other body coincide with each other, the charges from them, from this part, will move towards this part. Yes, it includes an electrostatic force. We included it. It's okay. As you say, we will going to deal with it. Then the concept again came up. What concept, Guruma? Then concept came to be, actually my students used to call me Guruma. It's our culture, Parivartan school. So it's okay. Please don't mind about if I many times if it would come up with me, because my students call me Guruma. It just stick to my tongue. Okay. So I would like to say, what kind of forces are there? See, gravitational force, frictional force, and many more forces are there. Then I say, no, forces are limited. I agree, there are number of forces accepted. There are number of forces, it is accepted. But yes, when we talk about all those forces, I can say still there is a foundation. He said, what kind of foundation you are talking all about? I didn't get you. Then he say, see, the gravitational force. Okay, let's talk about only attractional force, which is working on the whole planetary motion. The sun is attracting the earth. The sun attracting the earth, and the earth is attracting the moon. Then moon is attracting many other celestial bodies, small celestial bodies. Then we can say many more forces are working on this. Do these forces have any kind of relationship with gravitational force? Yes, all of them. So I can say gravitation force is a weak force. It deals with 10 raised to the minus 38 times of nuclear force. That means a nuclear force is much, much, much stronger than the gravitational force. It is a very weak force. Now you say, if gravitational force is such a weak force, how could the whole universe can stay with it? They should stay with nuclear force. I say, because the range of gravitational force is large. Yes, the range of gravitational force is very large, and also the mass of the object which we are considering in planetary motion is huge. Earth, huge. Sun, very huge. Universe, huge, 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 doesn't have any boundary. So yes, gravitational force works like that. Then we come up to electromagnetic force. The electromagnetic forces includes a number of forces in it. As I have told you, contact forces include in it, frictional forces include in it, electrostatic force include in it, electricity, moving charges force include in it. Then we say magnetic force include in it, electromagnetic force is also included in it. Nothing is, again I mean to say, a number of forces which are dealing in our universe, which are dealing in our current world, are related to electromagnetic forces. As you can see, there are two magnets, north and south, either be north and south, and in them there is a current flowing. So in between them, suppose that's a north one, that's a south one, and a current is flowing in between them. See, current is flowing across them. Current is flowing, passing through them like this. Magnetic flux is currently changing. How come magnetic flux is changing? As you have noticed, see here, see this part. These are charges. All of these are moving charges. And as charges are moving like in this direction, then I can say the current is flowing through them. And when a current carrying conductor is placed in transverse magnetic field, there will be an induced EMF. Yes, EMF will going to induce, and that's electromagnetic force that works. So it is due to stationary or moving electrical charge. Correct. Electrostatic, if we talk about electrostatic charge, electrostatic field forces, then it will come up in electromagnetic forces again. And if we talk about typically electromagnetic forces, then I can say magnet is stationary, but current carrying conductor or moving coil is moving. Coil is moving. If I say my magnet is moving and my conductor is stationary, there have to be one only. There have to be one which is moving on. Okay, then only the flux will change, then only EMF will going to induce. And in that case, we can say it is very much stronger force. You can say it's 10 to the power 36 times the gravitational force. That means huge. Still, it is very strong one. But 10 raised to the minus 2 times of strong nuclear forces. That means I can say the strong nuclear forces are the strongest of all. The number of forces you are dealing with, this force is strongest of all of them. Now we come up to next force. What are the next force? That is strong nuclear force. Now the question came up, it's okay ma'am. It could be strong, it could be weak, it should be a nuclear force only. Why have you divided these two forces? Concept came up. Yes, I can combine these forces. As I have made the fundamental forces, I have concluded the forces that is gravitational force. Number of forces are included in gravitational force. Number of forces are included in electromagnetic force. Then why I have divided these two forces? There is a wide meaning in behind it. And to understand that, we have to understand what is a strong nuclear force called as. As you have seen, there are protons, there are neutrons. Protons, when a neutron loses a charge carrier, or I can say, try to understand it in a simple way. Nucleons, the force between the nucleons is just the force between protons and neutrons. There was a question that if we talk about the electrical forces that lying between the charges, we all know the positive, or I can say the like charges. We always say that unlike charges attract each other. That means opposite charges, I can say. I can say opposite attracts. We use this in married couples also. We used to say husband and wife are opposite to each other. Then there makes a nice couple. Opposite charges attracts, and same charges will going to repel. Correct? Same charges repel. So, how could it be possible that a single nucleus having huge number of protons in it, how these protons as well as neutrons are combined in this? They have to repel each other. They have to repel each other as they have same charges. Yes, they are. But still, when they check out that protons are too much strictly bounded, the nucleons are strictly bounded towards each other, and they were not able to separate it. It makes the scientists, the researchers, the nuclear physics members to understand what is going on in this. How would it be possible that in spite of being same charges, they are attracting each other? The whole concepts of physics, the whole concept of Coulomb force, and the whole concepts of same charges repel each other and opposite charges attract each other, it got vanished. Thing to be think on. Then they have said, okay, we have to understand this thing. It is not always necessary that there would be only one force. If a ball is just rising up, see, this ball is rising up in spite of being in influence of gravitational force. How? Because I have given it much force than gravitational pull. The moment it has the gravitational pull, it will reach the height. The moment the gravitational, my force, the force I have applied it, has been reduced less than the gravitational pull, it will drop down. So, all right, the concept would become up same. They said there won't be any single force on the particles. There must be some other forces also that are ruling on them. After that, complete conversation, complete study, complete communication between the number of scientists, they have find out, yes, there is a strong nuclear force that lies between protons and neutrons, protons also, and they name them strong nuclear force. Their size, their range deals with 10 raised to the power minus 15 meter. As I have told you, physics deals with 10 raised to the power minus 14 meter to 10 raised to the power 25 meter. So yes, it includes in it. It is a part of nuclear physics. After that, one more concept has came up. They said, what is the concept? They said there is a concept of conversion of neutron into proton. As you see that red D which is demarked on, that is basically a nucleon. That's a neutron. Okay, so when this neutron, after the exercising, it after radioactive decay, I can say, after the radioactive decay, you can say radioactive beta decay, it converted into an electron as well as anti-neutrino particle. I'll tell you about anti-neutrino particle when you reach to grade 12, and it is there in the nuclear physics also. Then I'm gonna tell you what is a neutrino particle and anti-neutrino, you will going to understand. See, what is a neutron? Neutron is just a mass. When a charge, negative charge, will come out of that particular neutron, there will be existence of some kind of positive charge, and because of that positive charge, it try to convert into proton. So we can say operate within the nucleons, that is elementary particle like electron and neutrino. It appears during radioactive decay, and it is 10 raised to the power minus 13 times stronger than nuclear force. Minus 13 times. That means it is a weak force. With that note, they have studied a number of concepts, and they have become a new generation, a new world of physics. They have developed a world of physics that is called as nuclear physics. And they were actually very proud of. Yes, we are dealing in it. So it was a huge, I can say, research for all of them, that they have proceeded to such an important task. So with that note, They have come up to many other forces, as I have told you. Number of forces also come across them when they studied about nuclear physics. So I can say nuclear physics in itself is a very wide concept to understand, to think of. One more thing I would like to tell you. Physics is not only confined to laws and forces and motion. Physics is confined to many other concepts also, like the concepts of heat, thermodynamics. There are a number of fields, I can say. When we talk about motion, I can say the motion is basically a field of kinematics. Motion is a field of kinematics. The whole physics is confined to many other fields, and in that I can say first field is kinematics. I've already told you the kinematics, the motion deals with three parts. Static. What is statics? When the object is not able to move, object is not able to produce a motion, then it is statics. Then again, come up to next. What is that? That is, in that particular physics, I can say kinematics is a field, and in that kinematics field, there is statics where motion cannot be done. There would be dynamics where motion can be done, and we have to understand its attributes. Then another concept, that is, you can say mechanics, you can say. Yes, mechanics, in which we are going to do how, why, causes. Yes, there are a number of concepts of physics. So I can say physics deals with those type of parts. Okay, it's okay. Physics is end. He said, no, there is no end. I have already told you. Then they come up, what is the next part? Then they said, physics deal with atoms also. Atomic physics. He said, yes. In atomic physics, he used to understand about all the atomic and intermolecular forces which exist in between them. Then talking about interatomic and intermolecular forces, what are those? He said, you have heard about it. What kind of forces are there? They said they make bonds. They said, how? What kind of bonds? He said covalent bond, uh, metallic bonds. There are a number of bonds they used to form. Oh, he said, okay, we will going to pursue that also. It's okay. Then I can say, yes, physics has its own other fields also. What are those? Atomic forces. Okay, atomic forces. It's okay. Atomic physics is done. Then what is the next? He said thermodynamics. He said, what is thermodynamics then? He said, thermodynamics deals with motion occur due to rise in temperature, fall in temperature. Actually, there is nothing which is called as cold and cool. There's nothing like that. It is just a concept of heat. Heat is coming. That means body is having a heat. Body is hot. If heat is radiating from the body, heat is coming out of the body, then the body is cold. Then I can say, after talking about motion, so with that note, I can say my physics actually deal with kinematics, and then after kinematics, there are many other fields like thermo, I can say. Thermodynamics. Then atomic physics. What is going on in atoms, molecules, huh? Number of things are there. Then some more are there. What are those? Big question. Then he said, as I have told you, it doesn't end. Then kinematics I'm going to mark here because we need to mark on many other fields right now. So I'm going to write kinematics here. After kinematics, there is nuclear physics. I have told you. Nuclear physics. Then there is a concept of electronics. Though it is a different field now, but earlier it was a part of electricity only. Then electricity, moving charges concept. Okay. Okay, I'm writing here It's electricity. It's electricity. Then again, he said some more thing is given. Yes, magnetic field. Then there was another field that is called as magnetic physics, you can say. Then you said now it's end. Nobody, it's not end here. He said what's next? That is optics. Optics also. Yes, lights. Then he said again, what is next? Then he said there are many other fields like electrostatic. Electrostatic, he said, what is electrostatic? You have already discussed about electrical and electricity and electronics. Yes, electrostatic is again another field. What is electrostatic then? Electrostatic is a physics, is a motion, is a electrostatic is basically when current produced or motion of charges. वैसे motion of charges में ऐसा कुछ खास होता नहीं है. When the particle is charges are stationary, then the electrostatic field got created, the charges got created. That is included electrostatic. As we can do that, you can just rub a scale on your head and try to attract the small bits of paper. Yes, charge will going to develop. You can just took a glass rod and rub it with some kind of silk fabric, and then you will feel, yes, there is a traction or repulsion force. So there are many other forces which can be included over here, and we have to understand how they are dealing in current world. So with that note, I would like to end up